Number 65, our factors of 5 are, I put my dots too early. Of 5 are 1 and 5. Our factors of 16, 1, 2, 8. I should probably have 4 in there too. 4, 8, and 16. We'd put our fractions. Well, we'd have 1 over 2, 1 over 4, 1 over 8, 1 over 16, 5 over 1, 5 over 2, 5 over 4, 5 over 8, 5 over 16. If you look at your graph, it looks like 1 over 16 would be our 0 we would need to look at. It's going to be 1 over 16. It's slightly bigger than 1, so it might be 1 over 16. I guess it might look like 1 over 8 too. Those would be our two possibilities if I look at our graph. One of those two would look like our 0. So we would go ahead and divide 1 over 16 synthetically. So we'd have 16, negative 33. We would have 82. We would have negative 5, it looks like. Well, we go 16 here. 16 times 1 over 16 would be 1. Negative 32. Negative 32 times 1 over 16 would be a negative 16. That would be 76 minus 10, which would be 66. Maybe positive 66. Wait, did I make a mistake somewhere? Oh, that's what I did. Oh, okay, I know what I did. 1 over 16 times negative 32 should have been negative 2. That makes more sense. All right, and then we'd have 80. 1 over 16 times 80 equals a positive 5. That would equal 0. That is a factor, and so we would have x minus 1 over 16 times 16x squared minus 32x plus 80. I would set that equal to 0, where one of my zeros would be x equals 1 over 16. The other 0 comes from this 16x squared minus 32x plus 80 equals 0. To make your life easier, you'd probably divide both sides by 2. Possibly 4. 4 goes into all of it. 8 goes into all of it. Ooh, make it even easier. 16 goes into all of it. Oh, wow. So if we really want to save our time, we'll divide by 16. I do believe this one is not factorable. In fact, I think these are imaginary numbers. Just looking at it, that opens up, and it looks like it's going to be high. So you're going to have to put in the quadratic formula or complete the square to finish that off. Okay? Other questions? 5 times, we just did that. Liv. 81. What is 81 asking me to do? Is that the graphing one? Yeah. All right, so let's go ahead. It says use a calculator to basically graph this and answer your questions. Let's resume there. So we need to open our Wabbits or your calculators. If yours aren't called Wabbits, I don't know why they aren't. I got my Wabbit right there. I'm going to turn that bad boy on. I'm going to go to my y equals, and I'm going to type in negative x to the 4th since I don't have t's. So negative x to the 4th. Note, for those of us that don't use our calculator a lot, that's our to the power button. So if I have to go to the 4th, it'd be negative x to the 4th. Plus 12, that's 11. 11 x cubed minus 58 x squared. And then we should have plus 132x. And then when you graph it, you should get what I get as long as I typed it in correctly. It's hard to tell up here if I did it or not. We'll see in just a second. It should drop. There it is. We can answer our first question from that graph, even though we don't see much of it. It says, use the formula to determine when the drug will totally be eliminated from the bloodstream. So P of T is our Y value. That's how much, I guess, the drug is still in our system, where T stands for time in hours. So if we look at this, I want to figure out where it equals 0. Well, it equals 0 at time equals 6. Yeah.
I'm getting an error.
Hit zoom standard. Oh, syntax error. Go to your y equals. Make sure you don't have a
I added like a plus zero.
Oh, you use an actual minus out front? It has to be negative.
Oh, shoot.
Yep, that should fix it. All right, shh, guys. All right, so we're looking at where y equals 0. Y equals 0 right here at time equals 6. So our first answer will be t equals 6. At 6 hours, we'll have 0 drugs in our body. Our output is how much drugs in here. Our next one asks, what's the maximum concentration that was in the bloodstream? Well, the maximum concentration is going to be our vertex. It's going to be the tallest part of our graph. Well, if I look at this, it's dropping down here, which means our vertex is way up here. If you hit zoom out, you're going to have to zoom out so far you won't be able to see your graph. So instead, I just want to look up here. To just look up here, you're going to go to your window, and you are going to increase your y max. I just want to raise that up higher. Now, I know where I want to, but you would kind of guess and check. Maybe you'd raise it up 50, then maybe 100, maybe 200 then. I know 130 is going to be a good view for me, so I'm going to go ahead and do 130 as my y max. Now when I graph it, we should be able to see the top of our graph. Now, enough for this problem. If you ever hit left or right, you're going to see a flashy little blinky X. That will give you an approximate where stuff is. So if I bring that all the way to the top of my vertex, this will give me a good approximation of what value we're looking at. And that is a drug value of about 119. I think I put 120 in mine. The actual is 120, but I would have been okay with 119. And then it asks what time did that occur? That occurred at about 2.97 or 3 hours. So this is our time in hours. This is our concentration. The next question asks, I think, when is the drug above 80 parts per million or something like that? So they're asking you, when is this graph above where y equals 80? Well, you can't see that on here. So make your life a little easier and just go, okay, why don't I just make a line at where y equals, 80, I think it was. Why don't I just make a line at y equals 80? Oh, man, I just got to get that time there and that time there the same way by putting that little x on top of it. Now, if you ever need a more exact answer, we're going to talk more about this today, but you have a little calculate button right here. If you hit second and calculate on this problem, so I'm going to hit second and calculate. I'm looking for a maximum in that problem. So what you're going to do is you're going to scroll down until you get to that maximum. And what it's going to do is it's going to ask for a left bound. So you see my little flashy X right here? They're asking you to put somewhere to the left of where we're looking for. So I'm looking for right here. So I'm just going to put here and I'm going to hit enter. Then it's going to ask me to go somewhere to the right of that. So I'm going to move right until I get to the right of that top thing, which is about here. That's right of it. And then it asks for a guess. I hit enter, and it will actually tell me my maximum is at 2.9999999, which is 3, and my y is 117. So we were a little off on that answer key. That's our exact maximum. It does all that math for you. And we're going to use that today to find zeros. Because if you hit second calculate, you're going to see there's a 0 button in there as well. So if you missed what I just did, we're going to do it again, but with 0. All right. Other questions from the homework? That was probably too in-depth. Not wasted time. I think it was good use of time. Are there other questions? Gracie? For 63, you can't find a 0. Okay. 63, your rational 0 would be 3 of them. You have 1/2, 1/3, and 1/4.
I did 1/2 and I got 7.
Okay, let's just check it real quick. I've been wrong before, not on this one, but we'll see. So 1/2, and we're going to use synthetic division, if you're okay with that. -26, 9er, negative 1. All right, we carry down that 24. Half of 24 is 12, right? So negative 26 plus 12 is going to be a negative 14. Half of 14 is going to be negative 7. This will give me 2. Half of 2 is 1. That gives me 0. Yeah. You're welcome. Okay, let's go over today's lesson. Today's lesson is kind of not throwaway. It's just an extra nod to finding zeros. So we're starting off with what's called an en-route theorem. When I ask you to find all of your zeros, it's probably a good idea to know how many zeros you're looking for so you know when to stop looking. And you can't use a graph because they can be imaginary zeros. You can have 100 imaginary zeros. If you find none of them, you didn't end up being correct. So the en-route theorem says the degree of the polynomial is the number of roots it has, including multiplicity. So to figure out how many zeros you have, just go to your biggest power. So we have 6x to the 5th plus 24x cubed. Our biggest power is 5. Let's circle that in red. So there are, in fact, 5 zeros. Note, I'm not saying there's 5 potential zeros. I'm saying there's actually 5 zeros. You have to find all 5 of them if I say find the zeros. All right. So as solving this, I know I have to find 5 of these zeros. Well, I have 6x to the 5th plus 24x cubed. It looks like I can factor something out of it first. So I'm looking at 6 and 24. What can I pull out of 6 and 24? What? 6, yeah, 6. What's the biggest thing I can pull out of x to the 5th and x cubed? What goes into both of those? X to the 5th and x cubed. Yeah. X cubed with a question mark. All right, well, 6 divided by 6 is 1. X to the 5th divided by x cubed is x squared. Plus 24 divided by 6 is just going to be 4. X cubed divided by x cubed is 1, so we're just left with 4 equals 0. So we have two possibilities. Either 6x cubed equals 0 or x squared plus 4 equals 0. Let's look at the left-hand side. What's the only thing I can plug in for that x that makes it 0? Yeah. 0. So it looks like it's 1, 0. It isn't 1, 0. 0 is correct. And it's the only thing that works for this one. However, it's called a multiplicity of 3 because I can rewrite this as 6 times x times x times x, which equals 0. Any one of these x's could be 0. So when we have 6x cubed and we say, well, that means x equals 0, you're going to want to add on the fact that it has multiplicity of 3. So anytime you find a 0 to a certain power, if this was x to the 4th, I would say x equals 0, multiplicity of 4. To let myself know I already found 3 zeros. You found 3 out of our possible 5 zeros. That way you're not continually looking for things and going, that's only 1. That is 3 of our zeros. Our next one is x squared plus 4, so we would just subtract 4 from both sides. We'd have x squared equals a negative 4. I would take the square root of both sides. We'd have x equals plus or minus the square root of negative 4. Well, that's going to reduce down to x equals plus or minus. That would be I times the square root of 4. Square root of 4 is 2, so it would be 2i. That is all 5 of our zeros. There's 3 zeros here. And there's 2 zeros here. It's a plus 2i and a negative 2i. We have all 5 of our zeros accounted for. Once again, we have all 5 of our zeros. Our next one's a little trickier. How many zeros does the next one have? Note, it's not in standard form. Yeah.
7.
It would have 7 zeros. Correct. It would have 7 zeros. And let's think about how it would be 7 zeros. It has to be in standard form so I can know what power it is. If I would expand this, if I did x minus 3 squared, I don't care about this negative 3, but I know I'd end up with an x squared at some point. If I did x plus 14 to the 5th, I would at some point have x to the 5th. Well, x squared times x to the 5th equals x to the 7th. So if you have this chain of multiplications, you're going to use what's called the power rule. The power rule says if you're multiplying exponents, you add them. So by the power rule, there are 2 plus 5, which equals 7 zeros. Note, I didn't add 5 and 3 on the first one because I was adding between them. But if you're multiplying, then use the power rule to come up with 7 zeros. All right, so we have 7 zeros to find. Realistically, we're just going to find 2 with multiplicity because we have 2 possibilities. Either this x minus 3 squared equals 0, in which case it really would be x minus 3 times x minus 3 would equal 0, which means that we have x equals 3 with a multiplicity of 2. Well, our next one is x plus 4 to the, or 14 to the 5th. I don't know about you, but I don't want to write x plus 14 5 times. We just have to recognize that it's x plus 14 times x plus 14 plus x, or times x plus 14 times x. I forgot where I was at, but you do that 5 times. So rather than having to write all those out, you're just going to go, okay, because of this, x equals negative 14 with a multiplicity of 5. Because it's to the 5th power. There's 5 of those. X plus 14 times x plus 14 times x plus 14 times x plus 14 times x plus 14. There, I got it. 5 times. All right, that's how we determine how many zeros there are. We're going to use those in just a little bit. All right, we're going to get to kind of one of those other theorems that just kind of fits in here. It's called the conjugate pairs theorem. The conjugate pairs theorem says if a plus bi is a root or a zero of a function, then a minus bi is automatically another root. So if at any point I tell you there's an imaginary root, so say I say positive I is a root, you automatically know negative I is a root too without me telling you that. So our example is find a polynomial equation with roots 2 and 1 minus I. On the test, as soon as I ask you this question, you should immediately look at that 1 minus I and go, and 1 plus I is a root. And that comes from up here. So if I ask for an equation that has 1 minus I as a root, I am automatically asking you 1 plus I as a root as well. And so the only way you get that question correct is for you to add that in. Okay, for roots, we've done plenty of these where I say 2 is a root, and so we'd have x minus 2 somewhere in our equation. Because when I plug 2 in, I need to get 0 out. Well, the same thing's going to work for these guys. This is going to be x minus 1 minus I. So if I plug 1 minus I in here, this would all cancel out, and I would have 0. Same thing with x minus 2. Well, for the last one, we're going to do the same thing. We'll have x minus whatever's there, which is 1 plus I. Now we're going to link all of those together using multiplication. So we are just going to come up with some kind of function. Let's call it f of x. Is going to equal x minus 2 times x. Let's distribute that negative sign to make it negative 1 plus I. Times x. Distribute that negative sign. We'll have minus 1 minus I. If I plug 2 in, I would have 2 minus 2, which is 0. If I plug in 1 minus I in here, 1 minus I, we'd have 1 minus 1, which is 0. And I'd have a negative I plus I, that would be 0. If I plug 1 plus I in here, our 1's and I's would cancel out, and I'd be left with 0. That's all I'm asking you to do. Real quick, on the test, there will be a hidden bonus point on it. If you have time, probably not on this one will be pretty hard. If you want to put it in standard form, you can get a bonus point on the test. I believe the test one's a little easier than this one because this is a binomial times a trinomial times a trinomial, makes it a little harder. But in order for you to successfully do that, the first thing you should look at, and we'll put this as a little note to make it even possible for you to do that. What does I times I equal, Liv?
-1?
Yep, it equals -1. It's the only thing you can square and end up with a negative. That's what makes it imaginary. But that'll be a bonus point. So on your homework, if you want to try it on some of them, I did for most of them put the standard form on the answer key. So if you just want to practice putting it in standard form and see if you can do it, it is on the answer key. All right, so that is conjugate pairs theorem. Our next one is find all solutions to 2x cubed minus 5x squared minus 6x plus 4. All right, we're going to pretend we don't have a calculator. So we're not going to use our calculators at all on this one. So we're going to come up with our rational root theorem, which says that, well, find the factors of your constant. Factors of your constant, which would be factors of 4. And then we'll do factors of 2. Well, factors of 4 are going to be 1, 2, and 4. Factors of 2 are 1 and 2. So our possible answers are 1 over 1, which is 1. 1 over 2, which is 1/2. 2 over 1, which is 2. 2 over 2, which is 1, already accounted for that. 4 over 1, which is 4. 4 over 2, which is 2, I already accounted for that. If I was going to do one on the test that I said you cannot use your calculator, I would pick one that is pretty small. I might even pick one that's smaller than this. I might pick one that just has a 1, so just be 1, 2, and 4. Because if you don't have a calculator, you have to guess and check. There is no reason for what I'm about to tell you except to make it more successful on the test. On the test, start off with your smallest number. I'm not saying start off with your smallest negative number, which would be -4. I'm saying start with 1/2. Do positive negative 1/2, then try positive -1, positive -2, because what I'll do for that one is I'll pick one that has small numbers, and it will be the smallest of these ones that will work. That way you're only testing it once, twice, maybe 3 times. All right, I don't want you going through 20 of these. So if I say you can't use a calculator, I always go for that smallest value. So our smallest one is 1/2. So I'm going to start with 1/2. Remember, there's no mathematical reason for it. If you put that note in there, it's just to help you on the test. All right, so we're going to see if 1/2 works. So we have 2x cubed. We have a -5. We have a -6. We got a quattro. Carry down that 2. 1/2 times 2 is 1. -5 plus 1 is a -4. 1/2 of 4 is -2. -6 minus 2 is a -8. Oh, crazy. The one I picked worked. What are the chances I randomly did that? All right, so that is, in fact, one of our factors. That's a factor or a 0. So since 1/2 is a factor, what we actually did is we divided out x minus 1/2. That's the hardest thing to picture on these. I am plugging in 1/2, but I'm actually checking to see if x minus 1/2 is a factor. It's the hardest part about these. I'm saying if I plug 1/2 in here, I get a 0. That's why we have that 0 there. And we actually know the second part of this. Well, once again, if you want to, right above these 2, 5, or -5, you could put your x cubed, your x squared, your x, and your constant to let you know you drop 1 power. So it'd be 2x squared, -4x, and a constant of 8. So we're going to have x minus 1/2 times 2x squared minus 4x minus 8 equals 0. I already found 1, 0. We said that x equals 1/2 is a 0, so let's box that in. Our other 0 is going to come from this 2x squared minus 4x minus 8 equals 0. Be smart and divide both sides by 2. It's not going to change the world, but it can make things a little easier. So if I divide everything by 2, I'm going to have x squared minus 2x minus 4 equals 0. This isn't factorable. It looks like it, but it's not quite, because I have 2 and 2 going to 4, 1 and 4. Those don't add up to 4. So we're going to have to either complete the square or put in the quadratic formula. I'm going to complete the square. I always complete the square if this is 1. I think completing the square is easier. So that means I'm going to add 4 to both sides. Maybe I'll complete this a little higher for people that are trying to actually look at what's happening. I'll put that up there. So we are going to have x squared minus 2x plus something equals, moving a 4, I have to add 4 plus that same something. And that something is going to be negative b over 2 squared, negative b over 2 squared. If you're working on both sides of the equation, you add both of them. If you're working on one side for vertex form, you add and then subtract it. All right, then finishing off completing the square, we put the x down there. We put the negative 2 over 2, which is negative 1 here, squared, is going to equal 4 plus negative 2 over 2 is negative 1 squared is 1. That would be 5. Then we would take the square root of both sides and add 1. We'd have 1 plus or minus the square root of 5. How many zeros did I just find? I found 3. How many am I supposed to find? How do we know it's 3? We do.
Oh, yeah.
Yeah, because it's x cubed, we have 3 zeros. I hope we know, otherwise we're gonna we have to keep looking. All right, so we found all our zeros. Didn't use a calculator, we found all our zeros. All right, our next one, we're gonna heavily rely on our calculators. In fact, we're not even going to come up with our list of potential zeros. Instead, we're going to jump to our calculator and type in x to the 4th minus 4x cubed plus 7x squared minus 16x plus 12. And we got about 10 minutes to do this, so hopefully we don't run into too many roadblocks. First of all, I'll get rid of both of those equations I wrote in. Then I'm going to bring up my sheet so I make sure I write in the right equation. So we have x to the 4th minus 4x cubed plus 7x squared minus 16x plus 12. And then we're going to go ahead and hit graph. I'm probably also going to hit zoom standard at some point, because that's not helping me out much. Zoom standard. We should have a graph that looks like it has 2 possible zeros. Well, it has 2 zeros. Zoom standard. I always hit zoom standard so you can kind of see what I'm looking at. Do we see both of our zeros? I have 1 here, and I have 1 here. The nice part is these are nice whole number ones, so you could probably just look at it and know what your zeros are. But when you get to like 1 over 16 and 1 over 8, you're just checking to make sure it is 0, Brody?
How do I get rid of dimension mismatch or something?
Hit zoom standard.
That's what I still said.
You get weird stuff on. So. Yeah, get rid of your plot one. There you go. Make sure all your plots are off. All right, so I want to actually know what 0 this is. We're going to let the calculator do it for us. So we're going to go ahead and hit that second calculate. So once again, second calculate. It's going to bring up a list of things your calculator can calculate for you. One of them is 0. So we're going to go ahead and hit enter for 0. Once again, it's going to ask for a left-hand bound. You have a flashy X somewhere on here. You just can't see it right now because it's actually right up here. And you know where it is because it says X equals 0. Well, to move that X, you're just going to hit the right button. It's going to increase your X value. So I'm going to go ahead and start scrolling, and you're going to see a little X start coming down your line. It asks for a left bound, so I want something to the left of that point. That's about here. That's an X value less than what I had, so we're going to go ahead and enter there. And then it asks for a right bound, so we're going to go past our 0. And I'm going to go ahead and click. Remember, this isn't higher and lower. It's left bound and right bound. This is right of the point, because if I do a straight line, it'd be right of it. I'm going to go ahead and hit enter. Then it asks for a guess. The guess is not important. The only time it's important is if you have a crazy number of zeros, and it can't. So usually I just hit enter, but if you feel fastidious enough, we're just going to get close to it, and we're going to go ahead and hit enter. And you're going to see your y value is 0 at x equals 1. So one of your zeros is x equals 1. So we're going to go ahead and put that down. X equals 1 is a 0. And we know there's another one. Let's go back and find that other one. Once again, we're going to go ahead and hit second calculate. I'm going to go back down to 0. It asks for a left-hand bound. So I'm going to, if you look at my little x, I'm going to maybe go about here. That's left of it. Then it asked me to go right of it, so I'm going to make sure I go to the right of it. If you look at my flashy line, it's to the right of it. So I'm going to go ahead and enter. And then it asks for a guess. I'm just going to hit enter again, and it's going to do a good job. It's going to say x equals 3 is your other 0. So now we know for a fact 1 and 3 are zeros. How many zeros am I supposed to find? Oh, 4. And I don't know if these are multiplicity or not, so what we're going to do is we're actually going to factor them out and see what we're left with. So we're going to factor out a 1, we're going to factor out a 3. The only way we could do that is either synthetic division, or we use long division doing x minus 1 and x minus 3. I'm going to use synthetic division. So we're going to use synthetic division to factor out x minus 1. So with synthetic division, I don't need it that big. I'm trying to save some room. We're going to have 1x to the 4th. We have negative 4x cubes. We have 7x squareds. We have negative 16 x's. And finally, we have a constant of 12. And per the calculator, it should 100% work. Well, we carry down that 1. 1 times 1 is 1. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. 4. Negative 16 plus 4 is a negative 12. 1 times negative 12 is a negative 12. The calculator is right. It is factorable. So what we have right now is we just factored out x minus 1. So we have x minus 1 times 1x cubed minus 3x squared plus 4x minus 12. The good news is I have one more factor that I know will go into that evenly, and that is 3. If 3 goes into this evenly or comes out as a 0, x minus 3 will also go into this evenly. So I'm actually going to factor x minus 3 out of this portion of it to make it even smaller. So it's going to look like this. We're going to go 3. I have 1x cubed, negative 3x squared. I have 4x. I have negative 12. And that will also have a remainder of 0. So I'm just factoring x minus 3 out of this. Okay, carry down that 1. 3 times 1 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. 4 plus 0 is 4. 4 times 3 is 12. We are left with 0 again. Now we have a whole new equation. Not a new equation, but a new look to it. First of all, we factored out an x minus 1, so we're left with x minus 1 Then we factored out a 3. So we'd have times x minus 3. And then we're left with, well, that's going to be 1x squared plus 0x plus 4. Or more simply, we have x minus 1 times x minus 3 times x squared plus 4. Set that equal to 0. And we have x equals 1 is a 0. X equals 3 is a 0. And x squared plus 4 equals 0 is going to be a 0 when I solve for that. Let's subtract 4 from both sides. We'd have x squared equals a negative 4. Take the square root of both sides. You're going to end up with, I'm running out of room, so I'm just going to finish it off. It'd be plus or minus 2i. That is 1, 2, 3, 4 zeros. We are supposed to have 4 zeros. This is about as tough as they come because you have to factor it twice. And it's really hard to see that you're factoring when you're using synthetic division. So it's important you understand what I did and ask questions now if you don't understand it. Leo.
Can you reteach the how'd you plug in one? How'd you find 1 and 3 as that?
How to use your calculator to do that? Yeah. So do you have your calculator out, right?
Yeah.
All right. Do you have that graph in?
Yeah.
Okay. So what you're going to do is you're going to hit this second button and calculate. All right. It should bring up a screen that looks like that. Now we want to calculate a 0, so we'll either hit 2 or scroll down and go to that one. See how it asks for a left bound? Which 0? This one or that one?
The first one.
The first one. Okay, so we're going to find this 0, which means that flashy x has to be to the left of it. That means it has to have an x value to the left of it. So if you look at my x value here is somewhere about 1, right?
Yeah.
So I'm going to make sure to go to left of 1, which would be, I don't know, 0.85, 0.63. We just need to make sure that flashing line is to the left of it. And then you're going to go ahead and hit enter. Now it should ask for your right bound. So you're going to go to the right of it. So we got to scroll to the right until we're past that 0. So that's past that 0. Hit enter again. And then does it say guess?
Yeah.
Okay. We're just going to get close to it. And then hit enter. And that should come up with x equals 1, y equals 0.
Okay. And then how'd you do it for the other 0?
You're going to do the exact same steps. You're going to hit second calculate. You're going to make sure to go to the left of it. And then you go to the right of it. And then you'll make a guess at it.